Guys, today we're learning about natural logs. Natural logs. What do I mean by a natural log? I mean anything that has, a log with an e as its base. If you see this, it's the same as saying the ln of x. And if you see the ln of x, this can be rewritten just like that. Now we got to talk about a few properties. If you have the ln of e to the x, that just equals x. You know why? Because I spelled that wrong. Because the ln of e to the x is the same thing as me saying log base e of e to the x. And do you know what? This x pops down in front. Log base e to the e. This is the base, and that's the result. E to what power is itself? The first. E to the first is itself. So this quantity right here is just 1, and that's why you get left with x. But don't necessarily freak out or worry so much about this. Just take it in. Take it in. All right? These are not going to be specific, tricky questions. I just want to show it to you so you saw it once. What? It's the same thing as log e. See that? Read that.
Oh, okay.
It means the same thing. It's like you writing a script S or a normal S. They mean the same thing. They're written a little differently. Okay. And so finally then, you got to take down this one. If you see e raised to the ln x, that's the same thing as x. And then at the end, also with logs, if you have two quantities equal to each other and you ln up both sides, those two quantities are also equal to each other. Okay, so we took some notes. Let's practice. Let's practice up. Take this down. Take a look at it for a minute or two. Remember, we're not doing anything really new. No. You can do it. I believe in you. Let's do this, man. Let's do this. Anytime you see a problem where the variable is up in the exponent, guess what you got to use? Gil? What do you think, girl? Okay. Right? Take a look. Take a look. The 2x is linked to the e. The 2x is linked to the e. Let's try and get it by itself. What do you think we're going to do? We got to divide both sides by 4. Yeah. We're trying to isolate the e by itself. Trying to isolate the e. So in other words, e to the 2x, you know what 5 divided by 4 is? 5/4. It's also 1.25. So I'm going to take a minute or two. I'm going to pause. We'll let you guys ask some questions. Okay, so we talked about some different strategies, and I think where people were getting confused is like, when do I use ln? When do I use log? Let's go 2 separate routes once again. Method 1 and method 2. Either one is completely okay. Which one do you want to do for method 1, the old way or the ln way? Okay. So, you get to this step right here. Let's ln up both sides. So you get the ln of e to the 2x equals the ln of 1.25. The same rules that held for logarithms hold for ln because ln is a logarithm. So you get 2x ln of e. Should I use a capital L so you guys don't get confused by it being a 1, or are you all right with that? Here, okay. I'll use a capital ln. There you go. And now check it out. Check it out. You know what the ln of e is? So the reason you would choose to ln both sides is because the ln of the e, just by itself, not e raised to a power, is up over here next to the pi. Okay? So the ln of e is 1. So watch this. If the ln of e is 1, then the problem becomes ultra simple, and that's why you would go this route. Because if this is 1, then it turns out 2x is simply equal to the ln of 125. I'm sorry, 1.25. Divide both sides by 2. You get that x equals the ln of 1.25 divided by 2. And I think I asked you to round that to the nearest hundredth. So I'm going to give my answer in x form. I'm sorry, x is approximately what? 0.600? To the nearest hundredth, you're going to do the ln of 1.25, close that parentheses, divided by 2. And I think the answer is 0.11. Right? So that's how to do it the ln way. Anybody confused? Okay. We're going to do it the old school style, right? The way I've been teaching you all week long how to do it now. All week long. So you got to this step, method 2. Log up both sides. You get the log of e equals, the log of e to the 2x equals the log of 1.25, right? Same stuff occurs. Same stuff occurs. The 2 pops down in front. You get 2x log e equals log 1.25. Yes, that's exactly the case. The log of e, if you punch it into your calculators, is a big random number, right? So in one case, the method on the method 1, right, the ln of e automatically disappears as just 1. If you choose to go the log route, right, you actually have to divide both sides by the log of e. And so its next step would be this. 2x would be equal to the log of, yeah, I'm just not showing it. Divided by the log of e. And then after that step, you would literally have to divide it again so that it would be log 1.25 divided by log of e, whoops, all divided by 2. And I think if you punch that into your calculators, you're going to see that you get the same answer. It's just longer and it's more complicated. So some very smart person along the way figured out this ln business, and we use it every day ever since. Divided by 2. Same answer. Same answer. Okay. Let's play again. Let's play again. This is another type of problem that you might see. That looks hard, doesn't it? Come on now. Don't distribute the ln. Transform it. What does ln represent? Log with a what? With a base of e. Oh, how sneaky, right? How sneaky. Transform it again. Which one? Not like that. Transform it to exponential form. You're not failing this test. Why? How do you transform it to exponential? Know with all your heart that this is the base. This is the exponent. And this is the result. This tactic, this use of transforming like equations, is very much at the heart of trigonometry. We isolated the x. Let's plug it into our calculator. Let's see how much it is. We can't see it. How much is this? It is to the nearest hundredth. What is that? 10.39. It is 10.39. A very interesting number. Oh, you are correct. I forgot because we rounded to use the approximation symbol. Guys, LN's natural logs appear on your Regents exam, and what I passed out now is the actual, like, I printed out the page from the exam. You can see bottom left corner, you can always tell which test it's from. This is from January 2011, the most recent one. It's question 39. And on the back of the page, you please flip it over. Back on. On the back of the page is the grading rubric. That's what they give us, and that's how we award points. So if you open it up, you can see that this question was worth 6 points, and you can see how the points are given. So we're going to read the first part A of the problem. Read away, Dom. Okay, hold on one second. Temperature of 68 degrees. What variable is that? TO is the temperature of the room. So big TO. And I don't know if they taught this to you in science classes, but when you get a big word problem, you're supposed to take down notes on it. What all the variables are, try and figure out what you're supposed to be solving for. Okay, keep going. Yep. Hold on. No. We're going to read part B in a second. Okay. Okay, so we read through, for anybody that doesn't have the sheet in front of them, you could go print it out off regentsprep.org. But we just took down notes about the variables, and now guess what we're going to do with all those notes? Solve it. We're just literally going to plug them into the equation that was given. See? Plugged it in. Right? Now we're just going to simplify a little bit. 150 minus 68. I'm trying to work on my mental math. No calculator. 150, 118, 82. Forgot the equal sign there. And that looks horrible, and I can't have that on my notes. Equals negative. Okay, all right. What's next? We're trying to isolate K. So subtract that 4.718 over to this side. Minus 4.718 equals negative 3K. How can we get K by itself? Divided by negative 3, so that finally in the end, the ln of 82 minus 4.718 divided by negative 3 equals K. You actually didn't have to do anything. You just had to plug in some numbers and rearrange an equation. If you plug this into your calculator, do it in little parts, right? Do it in little parts. The ln of 82 minus 4.718, hit enter, divided by negative 3. It's 0.11. So, I'm sorry, not 0.11, 0.104 is equal to K. Was that difficult? Good. Sure. How long was it sitting in the room, Dom? So T is 10 minutes. It said use the value of K. The initial temperature of the room was how much? 68 degrees. And what is it asking us to find? Yeah. So we're asked to find, whoops, it's just getting all messed up here. We're asked to find what the temperature is. T. Interesting equation. Interesting equation. let's try and fill this out. So it's going to be the ln of, is it t minus 68? T minus 68 equals, I got it, Henry. It took me a little while there. Negative 0.104. Time was 10. And then what was that last number at the end of the formula? 4.718. That is the Bronx area code. That is kind of funny. Okay. No, I know. I'm over my normal time limit, but I've been posting so many videos and getting good reviews that they extended the amount I'm allowed to post for now. I don't know, truthfully. But I'm going with it. Now take a look. Do you see all this business over here? There are literally no variables on that side, so you could just punch it in. That's really an elaborate way of saying a particular number. What is the number? Just punch 3.678. Whoops, I chose a bad color. 3.678. Ah, we've seen this step before today. I would say we don't have to log it. I would say, let me give you a hint. You have to transform it. What's ln represent? With a base of e. What do you have to do? Ah, man. Hold on one second. Okay, so we're moving from this form. Transform again, one more time. E raised to the 3.678 equals t minus 68. And so therefore, that's why it was counting. It does sound like that. Yep. And then so when somebody gets done, when you guys get done copying it down, let me know how much, what t is for this case. Good job, Dom. But it says in the directions, what? Read it italicized at the end. So how much? I don't know. To the nearest degree.
Oh, I'm sorry.
Yeah. 108. 108. Felice, thank you for the correction. 108 degrees. We have one more question to do, and then we're done for today, and then you get your review sheet. Please open up your packets and turn to question number 14. It is proof that I teach. That we're not just playing cards in here. Lou? Short man. Here's a packet. Okay. So we got 6 minutes. We're going to be out of here. Real fast, real fast. Isn't it disgusting how fast bacteria grows? Disgusting, especially for a neat, clean person like myself. So here's the deal. Here's the deal. What did it tell you? This B of T business over here. This represents bacteria in what? Nope. Bacteria in thousands. And so they want to know, and the equation models the growth of bacteria. They want to know when will there be 1,000,000 bacteria? Thousandths. So my question is that if bacteria is in thousandths, how many thousandths are there to 1,000,000? 1,000. 1,000 thousandths is 1,000,000. Because you could have $100,000. Can you have $1,000,000? No. $1,000,000 is 1,000,000. It's even hard to say. You know what I mean? 1,000 thousandths. I just made 1,000 thousandths. That's ridiculous. I made $1,000,000. Okay. So if you have 1,000 thousandths, then this number over here is 1,000. That's going to represent 1,000,000 bacteria, those disgusting little creatures. No, I'm just kidding. Sorry, bacteria. I didn't mean to offend you. Let's do this. Let's do this. All was not lost. We did this all week long. Don't let new stuff freak you out, right? What do you think we do first? No, we can't drop that t yet. Good. Divide by 1.25. When you divide both sides by 1.25, what do you get? 1,000 divided by 1.25, Luna. How much is it? 800. 800. 800 equals 2t. Guess what? Guess what? Guess what we're gonna do next? Nah, you can't divide by 2 because the t is stuck in that spot. Anytime you get a variable stuck up in this spot, what kind of things are you going to use? Yeah, you're going to log them. Log it up. Log it up. Yes. Once you start to use logarithms, all the rules and properties of logarithms start to apply. That's the best part about them. That's why we use them. Shoot. Nope. Short answers are going to be just like these. What? Divide by log 2. What? 47 minutes, girl. Don't give up. You're getting too down on yourself. You can do this. Believe it or not, this is not that bad. Exactly. You can do it. Yep. Ugh. Ugh. To the nearest hundredth? Ooh. Do you know what that means? Ooh. That means this is gross. This is gross. After just 9.64 hours. Ugh. There's a million bacteria. After the first day of school, there's like a million bacteria on your desk. Literally.